Hello everybody, my dear mathematics section students. Today we will talk about center of gravity. This part introduced in the period of coronavirus spread. God save you and save our dear country. Firstly, we should know some remarks that help us to solve different examples on center of gravity. Center of gravity is the point that the resultant weight of the body act and its coordinates is g x bar and y bar. G meaning the distance, x bar meaning the distance between g and x axis, and y bar meaning the distance between g and y axis. Number 2, we can find the center of gravity using the rules x bar equal definite integral from a to b x e dm over definite integral from a to b for dm, and y bar also definite integral from a to b y e dm over definite integral from a to b dm, and dm meaning mass of the element. Now, to find x bar and y bar, we should have value of xe and ye and value of gm, or the expression meaning equal gm, and value of a and b limits of integration. Note, now we should know types of elements and its densities. If we take an element which like length element in shapes rod or circular arc or straight curve, then its density is lambda. If the example about thin rod, we use gx to represent length element. If the example was about any curve like straight or circular arc, we use gl to determine length element. If we take surface element, then ds is the area of the element. In the examples of area bounded by two curves, all we find word lamina or word plate. We use density sigma, which is called surface density. If we take volume element, then we have dV, which is mean volume of the element, with density rho, which is called volume density. We take this in examples: solid sphere, spherical shell, solid cone, empty cone, rotational body. Now we should know different types of GM according to different type of elements. If we take length element, then GM equal length of the element times its length density. So in rod, dm equal lambda dx. In different curves, dm equal lambda dl. In surface element with density sigma, dm equal sigma ds, surface density times area of the element. In volume element with rho volume density, then dm equal rho dv, volume density times volume of the element. That's different type of GM according to different type of elements. Firstly, let we talk about length element and its position xe, ye. Firstly, for thin rod of length 2a. Let we have a rod of length 2a. This rod of length 2a, we take an length element, that's length gx, To determine the position of the element, we taking point on x-axis. That means that this point coordinates is equal x, e, y, e equal x and 0. To find the limits of integration for rod with length 2a, it will be x between 0 and 2a. That is the limits of integration. For circular arc with radius a and central angle 2 alpha, as shown, by taking length element b1, b2, we have central angle 2 alpha. This is equal alpha, and all this equal also alpha. We have other two angles. The first is angle theta, which is from b2 to x-axis is equal theta, and the angle between b1 and b2, it's part of theta. We can say that it's equal d theta. We want to find length of the element. To find length of the element, assume that b1 and b2, b1 tended to b2, then it can form right triangle as shown. So we can find sine d theta, which is equal to b1 b2 over a, and b1 b2 equal a sine d theta. As d theta is very, very small, so sine d theta equivalent to d theta. Then b1 b2 can be written in the form a d theta. To determine the position of the element xe and ye, we draw projection from the arc b1 b2, cuts x-axis in point N, and make a right triangle as shown with an angle theta. So we can find xe and ye. Xe is equal a cosine theta, and ye is equal a sine theta. To find limits of integration, where the central angle is to alpha, then theta is between negative alpha and alpha. The limits of integration is negative alpha and alpha. 3. Asteroid curve. That shape is a asteroid curve which cuts x-axis and y-axis in points with distance a and 0, negative a and 0, 0 and a, 0 and negative a. And its equation is given by x power 2 over 3 plus y power 2 over 3 equal a power 2 over 3, which is given in our examples. Now we will take a length element. As we deal with curve by taking length element with length dl as follow, we want to find dl. dl is a part of its curve. As shown, we can find the relation between dl and dx and dy to find the value of dm as it equal lambda dl. That's rule we can find. Using it, we can find dl. We note that it's depend on value of dy over dx, which we can find it by using equation of asteroid. Using equation of asteroid, we can find dy by dx to solve and find center of gravity for asteroid curve. And position of the element we will take, that general point in asteroid curve, which is equal to x and y, any point, general point. And limits of integration, which is cuts x-axis and y-axis in point distance a, then x is between 0 and a when we're using dx, Now we will solve some examples on center of gravity about length element. Example 1. Determine center of gravity for thin rod with length 2a. This is rod of length 2a. We will take length element with length dx and mass element dm will given by lambda dx. To find the position of the element. Position of the element depend on this point. This point is on x-axis, then xe and ye equal x and 0. And limits of integration, as the length of the rod is equal to a, then it is x between 0 and 2a, depend on length of the rod. To find center of gravity. To find center of gravity, COG is the center of gravity. Finding x bar. Firstly, we write the rule of x bar, where xe equal x, gm equal lambda gx, and so on, gm also equal lambda gx. We can cancel lambda with lambda, which are constant for the same body. Then the integration will be integration from 0 to 2a for x dx, and also integration from 0 to 2a gx. Integration for x is x squared over 2, x squared over 2 from 0 to 2a, and also integration for gx is x from 0 to 2a. We put x one time by 2a and another time by 0. So it will equal to 4a squared over 2 over 2a. We can find that x bar will be equal to a. Secondly, to find y bar, where ye equals 0 in the example rod, y bar equal ye gm over integration 4 gm, so y bar it will equal 0. Then center of gravity equal a and 0 for thin rod of length 2a. We can note that the center of gravity for uniform thin rod is point in the middle of the rod. Example 2. Determine COG for circular arc with radius a and central angle 2 alpha. Then deduce center of gravity for semicircle. Firstly, we deal with circular arc. Circular arc. That means that we deal with types of elements which is likely length element. Then also dm will equal to lambda gl. Lambda times length of the element. By taking length element with length b1, b2, to find b1, b2, assume that b1 is very, the distance between b1 and b2 is very small, as b1 tended to b1, b2. It can form a right triangle b1, b2, with angle d theta. Then we will find sine d theta, which equal b1, b2 over a. So b1, b2 equal a sine d theta. As d theta is very small, so sine d theta is equivalent to d theta. Then b1, b2 equal a d theta. To find gm, we know that gm is equal lambda times the length of the element, so gm equal lambda a d theta. To find or determine the position of the element xe and ye by drawing projection from the arc b1 b2 to x-axis and cut it in point n. Then by using angle theta we can find xe and ye, as xe will equal a cosine theta and ye equal a sine theta, and limits of integration for central angle to alpha will be from negative alpha to alpha. To find center of gravity we will find x bar and find y bar. We write the rule of x bar. X bar and xe is equal a cosine theta and gm equal lambda a d theta, and also gm equal lambda a d theta. We can cancel a by a and lambda with lambda, so the integration will be integration from negative alpha to alpha a cosine theta d theta over integration from negative alpha to alpha d theta. Integration for cosine theta is equal sine theta from negative alpha to alpha. Yes, from negative alpha to alpha. Then it will be sine alpha negative alpha over alpha minus alpha. We note that sine alpha is odd function. Sine alpha is odd function. That means that sine negative alpha equal negative sine alpha. So the sine negative will be positive and sine negative alpha will be sine alpha. So the result will be a times 2 sine alpha over 2 alpha. Cancel 2. Then x bar equal a sine alpha over alpha. That's the value of x bar. To find y bar, finding y bar equal integration yegm over integration gm. Ye equal a sine theta and dm lambda a d theta over integration dm lambda a d theta. So can cancel lambda a with lambda a. The integration will be integration from negative alpha to alpha a sine theta d theta over integration negative alpha to alpha d theta. Integration for sine is equal negative cosine. Then the integration will be negative a from negative alpha to alpha. Integration will be negative a cosine alpha minus cosine negative alpha over alpha minus negative alpha, where cosine is even function. So cosine negative alpha equal cosine alpha. Cosine alpha negative cosine alpha equal 0. Then y bar equal 0. Center of gravity for arc with central angle to alpha and radius a is equal a sine alpha over alpha and 0. We want to find center of gravity for semicircle. The measure of central angle here will equal pi. So alpha will be pi over 2 as we deal with 2 alpha. Then the center of gravity will be a sine pi over 2 over pi over 2 and 0. Sine pi over 2 equal 1. That means that center of gravity g x bar and y bar equal 2a over pi and 0. Note that if we find integration for odd function from negative value to the positive value, the same value but positive, then it equals 0. So from previous example, we can find y bar integration from negative alpha to alpha for sine theta, it's equal 0. Example 3. Determine center of gravity for asteroid curve with equation x power 2 over 3 plus y power 2 over 3 equal a power 2 over 3 in the first quadrant. We note that we will take a length element with length GL. To find GL, we will find the relation between GL and GX and GY. Then GL equal square root 1 plus GY over GX all squared times GX. To find GY by GX from its equation, x power 2 over 3 plus y power 2 over 3 equal 8 power 2 over 3. To find its derivative with respect to x power 2 over 3 will be 2 over 3 x power negative 1 over 3, and y power 2 over 3 will be 2 over 3 y power negative 1 over 3 times dy by dx, where a is constant, then it's equal here 0. Cancelling 2 over 3 from both sides by dividing on it, then it will be x power negative 1 over 3 plus y power negative 1 over 3 dy over dx. To find dy by dx, we can write it in the form, we put x in the other side, then y power negative 1 over 3 dy by dx equal negative x power negative 1 over 3. We divided it by y power negative 1 over 3 to find dy by dx. So it will be dy by dx equal negative x over y power negative 1 over 3. We will put it in 1 to find GL. So GL will be square root for 1 plus y over x power negative 2 over 3. We can write it in another form. We put the fraction x over y by the negative power in the form y over x by the positive power 2 over 3. We can find the common denominator x power 2 over 3, then it will be x to the power over 3 2 over 3 plus y to the power 2 over 3 over x to the power 2 over 3. Here we can use the equation of the asteroid. That's mean x power 2 over 3 plus y to the power 2 over 3 equal a to the power 2 over 3 to find GL. By taking root, then GL will be a power a1 over 1 over 3 over x power 1 over 3 at all GL equal a power 1 over 3 times x power negative 1 over 3 gx. We can find now gm, which is equal to lambda GL. gm lambda GL, we have now value of dm, and we say before that we choose in asteroid curve a general point. That means that xe and ye equal x and 0, and limits of integration will be 0 to 2e. Now we should find center of gravity COG. We write the rule of x bar and xe equal x and dm lambda a power 1 over 3 times x power negative 1 over 3 gx over integration from 0 to a lambda a power 1 over 3 times x power negative 1 over 3 gx. We can cancel lambda with lambda, and a power 1 over 3 by a1 power 1 over 3. So the integration will be x bar equal integration from 0 to a x power 2 over 3 dx over integration from 0 to a x power negative 1 over 3 dx. Integration x power 2 over 3 will be x power 5 over 3 over 5 over 3, and integration x power negative 1 over 3 will be x power 2 over 3 over x power 2 over 2 power 2 over 3 only. Let we see 3 over 5 x power 5 over 3 from 0 to a, and over 3 over 2 x power 2 over 3 from 0 to a. We can put x time one time equal a and another time equal 0 to reach this form. So we can find now x bar as 3 with 3 and 2 and 5, then it equal 2 over 5 a, that's the value of x bar. To find y bar equal definite integral y e gm over definite integral for gm, where y e equal y and dm equal lambda a power 1 over 3 times x power negative 1 over 3 dx over from integration from 0 to a lambda a power 1 over 3 x power negative 1 over 3. We can cancel lambda with lambda and a power 1 over 3 by a 1 power 1 over 3. So the integration will be from 0 to a y times x power negative 1 over 3 gx over integration from 0 to a x power negative 1 over 3 dx. Let this relation is 2. We can do this integration dx, and now we have y. We should find the value of y in terms of x by using straight curve equation. To find y, we can put x in other side, then y power 2 over 3 equal a to the power 2 over 3 minus x to the power 2 over 3, raising two sides 2 power 3 over 2 to find value of y. So y equal brackets a power 2 over 3 minus x to the power 2 over 3 all power 3 over 2, and put it in relation 2. So we can see that value of y bar equal integration from 0 to a brackets a power 2 over 3 minus x to power 2 over 3 all power 3 over 2 times x to the power negative 1 over 3 dx over integration from 0 to a x power negative 1 over 3 dx. Let this is I1 over I2, and this relation is number 3. To find I1, let we do simple test for derivative for the function inside the brackets, which is equal 2 over 3 negative 2 over 3 x power negative 1 over 3. Now we should multiply it by negative 1 negative 2 over 3 inside and negative 3 over 2 outside. We can, using direct integration, we adding 1 to the power and dividing on the new power. So 3 over 2 will be 5 over 2 over 5 over 2, and all times the fraction 3 negative 3 over over 2. All from 0 to a. We put x one time equal a and another time equal 0. If x equal a, then it will be a power 2 over 3 minus a to the power 2 over 3, which equals 0. Secondly, we put x by 0, then it equal negative all a power 2 over 3 minus 0 all power 5 over 2 times negative with this negative, positive 2 with 2, then it is equal 3 over 5 a power 2 over 3. To find I2, look for I2, we find it in x bar, as in x bar we have the same integration, so we take the value of this integration direct, which is equal to 3 over 2 times a power 2 over 3. That's the value of I2. We put from 4 and 5 in 3, I1 over I2. We can find y bar, can cancel 3 by 3 and will be 2 over 5 e. So the COG, center of gravity, for a straight curve is equal to 2 over 5 e and 2 over 5 e. That's all for today. Thank you for all. Thank you.